Hello everyone, and welcome to another episode of our Accolade tutorial. Today we're going to be talking about something that is quite specific, but really useful and very important, which we call working with forks. This is part of a broader strategy that we call metadata as code, right? Metadata as code is all about making sure that you can collaborate with all the different stakeholders in your organization around one single source of truth, which is the repository of your data models, which is the Git repository. This is where you'll store your data models, where you work on your data models, where you version your data models, where you generate schema contracts from your data models, and where you also make sure that it's constantly in sync with your application code. So the Git repository is obviously a really important part of this metadata as code strategy. And it's important to understand that there are different ways to organize these repositories. Essentially, you've got two types of strategies that are important here. Every customer will want to have one of these strategies. First of all, wants to think about how you organize your repository, and there are basically two alternative options. One option is for you to create a shared repository. The other option is for you to create forks of that repository and pull them into the main repository as you see fit. Let's talk about that in a little bit more detail. The shared repository strategy means that all the contributors are granted push access to that single remote repository, that single central storage of all of your models, all of your code, everything that you want to share with the stakeholders. Then when you have important changes that need to be made to that shared repository, you make a branch of it, right? We've shown this in our workgroup collaboration tutorials. You can create branches of your repository, work in those branches and bring them back into the main repository as you need to. For example, working with feature branches. This process is called the pull request process, where people initiate these peer reviews, discussions about the changes that they are going to be making to the repository prior to merging them into the main branch. This strategy, the shared repository strategy, is very prevalent with small teams, with organizations that are working on private projects. It's a much less common strategy in larger projects or in public-facing projects where, for example, open source collaborators are working together on a particular project. This is where the fork and pull strategy is much more common. This is the second strategy that you can use to organize your repositories. Essentially, what you're asking people to do here is that every contributor creates their own remote copy of the original repository and constantly works in that repository as if it is their own. They are working in their fork of the original repository. When they have finished their work, when they have a contribution that is ready and that can be submitted, they create a pull request, and basically the contributor then asks the maintainer of the original repository to pull the work that they have done in the fork into the main repository. Also note that the forked repository, right, the one that the contributor had created from the original main repository, it's an independent repository, right? So people can work together in that fork prior to bringing it back to the main original repository, right? It's an independently operating repository. The nice thing about this, the advantages of this fork and pull strategy, as we call it, is that contributors don't really need to be having push access rights to the original repository. There's always a two-step process, so to speak, where you first have to commit and push to the forked repository before you can actually put it into the main repository. So that's why this is typically used for these large-scale open source projects where many of the contributors are just not known, right? We don't know who they are. Right? We may know their Twitter handle or their GitHub username, but that's about it. It really does prevent the original repository from being polluted. That's why this strategy is quite common among these public-facing projects. The fork and pull strategy is actually really interesting because it's not just a technical strategy, it's also more of a cultural strategy. Right? It relates to something that is called inner source, which is adopting the practices of the open source community inside enterprises. The assumption is that, learning from these open source projects, large teams inside enterprises can also improve their collaboration by adopting some of these practices. So it's a cultural shift which very much aligns with what we've talked about in separate tutorials called domain-driven data modeling, where contributors, people like architects, modelers, but also subject matter experts, and the project leaders and key decision makers of the projects are actually the maintainers that make sure that the main repository of a project is always safe and sound. So how do you get going with this? Well, the first thing obviously is that you need to create a fork. We'll show this later on in the demo. It's a little bit different in the different Git providers. In GitHub, GitLab, Bitbucket, or Azure DevOps, it's a little bit of a different process, but still very similar. Once you have created the fork, you can actually clone that in the Accolade Studio. You don't need a separate tool for that. You can do that inside Accolade Studio. But you should note that the fork and pull strategy that we've just discussed is currently only supported for GitHub. We'll add more providers shortly, but today it's really something that is GitHub specific. Once you have the fork on your local machine, you've cloned it onto your local machine, it's like working with any other repository. The difference really comes into play when you start contributing from a fork. Submitting changes for review from a fork is a little bit different. If you are submitting changes that are ready to be reviewed by the maintainers of the original repository, which is called upstream, then you should open a pull request in that repository directly. If you are collaborating with other contributors in the fork and your changes are just an intermediary step, then you should open a pull request inside the fork itself. So there's also important functionality around keeping a fork up to date. You forked a project from an original upstream repository. Now, obviously, the original upstream repository keeps evolving, just like your fork is evolving, and you will at some point want to update the fork with the functionality that has been added to the upstream repository. This is something that you need to take into account, obviously. And you will see that there's a specific functionality that you would want to review. The main principle here is obviously also that you need to pull before you push. So you need to have the most up-to-date version of the upstream repository in your local clone before you can push it into the main repository, right? So you need to keep it up to date. In order to do so, it's very useful to have comparison functionality. You can actually make the branches of the upstream repository available in your local clone of your fork, and then you can compare them. You can see them in the history view, and you can see how they compare to each other. You will also see that there are specific prefixes that are useful to see where you are working in. So the origin / prefix, that means that it's your fork. The upstream / prefix means that it belongs to the upstream repository. In the history view, you can actually compare arbitrary commits, right? You can review the differences between your fork and the upstream repository. Note that it's also really useful to use the filtering view on the history view so that you see what has happened in a particular repository specifically. In the case that you are actually the maintainer of a repository, so that means that you have edit rights to the upstream repository, right, not the fork, then you will also have additional functionality, which means that you will be able to compare the progress that has been made in a given fork to the upstream repository that you are in charge of. Great, why don't we take a look at how this works and go into a little demo. All right, let's dig right in and show you a couple of things here. Please also take a look at the documentation, right? So working with forks is a really elaborate piece of documentation that we have here on our documentation page. Take a look at that, and then we'll hopefully make things a lot clearer for you. But let's show you right here. The first thing that I need to do in order to start working with a fork is I need to create a fork, right? And what I'm going to be doing here is I'm going to be creating a fork of a library that we have over here. So it's the sample data models library that Accolade publishes on our GitHub account. This is the repo that I'm going to be forking from, right? So this is the upstream repo. I'm going to be forking that because I want to add some stuff to this sample model library. So let's do that. I'm going to grab the link over here, and then I'm going to switch to my Accolade Studio, and I'm going to clone this, right? I'm going to clone this repo into my local machine here. So to do that, I'm going to go to my GitHub drive over here, folder over here, and I have a sample data model folder here, and I'm going to create an upstream folder right there. So let's create that, let's open that, and now we're going to have a local copy of the upstream repo. The next thing I'm going to do is I'm going to actually fork this. So I'm going to fork this repo, and I'm going to create a new fork, which I'm going to call Rick's sample data models, right? Forked by Rick. And now this fork is available over here on my personal GitHub account. And I'm also going to clone this one. I'm going to clone this to my local machine. In order to do that, I am going to do the same thing here for my URL. And this is the URL. I'm going to clone it, and I'm not putting it in the upstream directory. I'm going to call this the forked directory. And this is where I'll put my fork. So now if we take a look at my local directory structure over here, you can see that this is the upstream one. This is a repository that I do not have write access to. It's being maintained by someone else inside Hackolate. And this is my repo, right? The forked repo, to which I obviously do have write access. And what I would like to do, obviously, is I would like to make some changes to this repo and then push them into the upstream main repository. So that's what we're going to be trying to do now. So I'm in my Hackolate studio and I'm in the forked repository in the main branch there. What I'm going to do now is I'm going to actually create a new data model, right? It's the same data model that I've used in many different examples. I'm going to connect to MongoDB Atlas and I'm going to reverse engineer a particular set of collections that I know are really interesting to play around with, and I'm going to create a new data model on my fork, right? So this is now here. I'm always updating this thing because it really doesn't matter. So now I have a new model, and I'm going to save this inside my fork, and I'm going to do that inside the MongoDB directory over here. And I'm going to say this is the mflix from Atlas model, which, if I go and take a look now over here in my directory structure, right, it wasn't there yet, right? So we have quite a few examples here from MongoDB data models, but the mflix example wasn't there yet, and now it is, right? So that now has been saved to my local fork, and obviously I want to push that. I want to commit these changes, pushing the mflix model to my fork. Commit and push that into my fork, right? So that's been done. And so now the next thing that I'd like to do is I would like to submit this new addition to my fork for review. I'd like to create a pull request in the upstream repository, right? And I'm going to try and request that this change that I made is going to be added to the main of the upstream repository. And what I'll do is I'll add a little title here, adding the mflix model to the MongoDB sample collection. Thank you for adding this, right? And then I'll add a pull request. As soon as I now switch to my upstream repo, I will actually see that there's a pull request waiting over there that needs to be reviewed. You can see some details here inside this pull request. Now, while I wait for the pull request to be approved in the upstream repository, I can obviously still work inside my fork here, right? So I can go and find the mflix model in my fork here, open it up, and I can, for example, do some work here and say, okay, I'm going to add a collection. This is the animals collection. Inside that collection, I'm adding an attribute. Inside that attribute, it's going to be an ID, right? So this is going to be an ID, an object ID. And I'm going to add a name for the animal, which is a string. And I'm going to refer that to the movie ID, which is actually going to be an object ID that I'm going to link to the movie ID over there. Over here, I am going to adapt the cardinality, and then we have another addition to the data model in the fork, right? And I'm going to save that and commit it to my fork, right? So I'm going to adding a new entity to the fork and push that into my forked repo. So let's show you what this looks like from the maintainer perspective, right? The maintainer of the upstream repository. So Thomas, my colleague at Hackolate, he got this view inside Hackolate Studio, which is basically that, he's getting a request to approve a new pull request, right? Once he does that, he can look at the details of that pull request and assign himself to that pull request. Once he thinks everything is okay, he can approve the pull request, and once that's been done, he can also merge the pull request into the main repository of the upstream repo. So let's switch back to my view as a contributor, right? That's me trying to contribute to a fork of the upstream repository, and let's see what that looks like over there. In the meanwhile, if I go back to my upstream repo over here, right, so the one that I forked from, I can now see that something has changed here, right? My pull request seems to have been approved. Someone has just approved this, and that means that it's now in the upstream repo and that I actually need to pull. Thomas, he has merged the pull request, and I can now pull this into my upstream repo, right? So that's great. So now if I access this file in the upstream repo, right, so I'll go over here and I'll find it over there. I can now see that the new model has been added to the upstream repo, and that it actually includes that last commit that I did to the fork. But I should also know that in my local fork, right, in the fork repo, I can still do some work, right? I can still do whatever I need to do. And over here, you will see that what I've actually been doing is I've added another entity to the repo, which is the cars entity, right? So there's another entity. I had the animals over there. I have the cars over there, cars in movies, right? But I have committed this to the fork, but I have not issued a pull request yet. And so therefore, right, if you now go over here to my history view, you can actually see that the cars is ahead of the upstream repo. I can still make some changes there. These changes here are actually small changes to the fork. I didn't commit those, but you can now see that, yeah, this is actually a little bit ahead of the upstream repo. So if Thomas would like to pull this into the upstream repo, then again, I would need to issue a pull request and do everything like that. Now there's some great additional functionality that I can still show you, right? Like you can compare a fork with the upstream repository. You can actually do the reverse, right? Compare the repository with one of its forks. But in order to do that, I actually need Thomas to help me, and I have asked him to create a couple of screenshots, which we'll go over right now. So the first thing that Thomas has done is to make it easy to track progress in the fork and compare it with the upstream repository. He has added the fork as an additional remote in the history view. Then this additional remote gives him access to the commits from the fork in the history view, and therefore to the ability to compare them with the commits from the upstream repository. Then he can also compare the upstream with the fork. And last but not least, here's the comparison, and that really wraps up the illustration of the maintainer's view of all the work that we have discussed here. And that concludes the demo of the fork and pull strategy and how you can work with forks inside Accolade Studio. I would like to point out that there are really great reading materials available. Look at our documentation, look at our blog, our socials. Take the product for a spin. It's the best way to get to know the awesome functionality that we have in the product. And then of course, if you are eager to learn more, take a look at some of the books, right? We have the MongoDB book, which was one of the first, but there's been added a number of other books that are using Accolade Studio as part of their explanations and illustrations for Neo4j, for Oracle 23c, for Elasticsearch, and there are more coming very, very soon. Thank you for your attention, and I wish you a wonderful rest of your